Happy morning, my dear children. Today we are going to discuss about the group 13 elements. Okay, especially for the boron compounds. What are the boron compounds means? Example is borax. Okay, what are the preparations, properties, and uses? Okay, please all of you take the note. We can discuss one by one. Today, our learning objectives to learn about group 13 elements. That is about the boron group, otherwise boron family. The boron occurs mostly at borates. Here, the important words are two. One is about that borax, other one is about that kernite. Borax, kernite. What is the formula of borax is Na2 B4 O5 OH 4 times 8 molecules of water. What is about the kernite? Na2 B4 O5 OH 4 times 2 molecules of water. Okay. For the one we have to learn this one. Next, we know the next element from the 13 group is about the aluminium. What is about the aluminium? The most abundant metal that is occur in oxides and also found in aluminosilicate rocks. Am I right? We know that already we learned about that aluminium ores, about the bauxite. Am I right? So it is extracted from bauxite ore. What is the formula for bauxite ore? Al2O3, 2 molecules of water. This is about the aluminium. What is the next element? Gallium, indium, and thallium. Am I right? Here, gallium, indium, and thallium, they are occurs as their sulfide ores. Okay, sulfide ore. That we can be discussed later. Okay, next about what are the physical properties of this boron family. First one about the physical state. This all element occurs as solid. Okay, solid. All elements. That means boron, aluminium, gallium, indium, and thallium. These are all occurs in solid state. Okay. Next about what are the atomic numbers of this family, this boron group, that is 13 element. Boron is about that 5, atomic number is 5. Aluminium atomic number is 13, just means we are adding 5 plus 8. What is about the 5 plus 8? 5 plus 8 means 13. Okay. Next about the gallium, that is 13 plus 18. What is that one? 13 plus 18 means 31. Am I right? Okay, then 31 plus again 18. What's that one? 49. 49 is the atomic number of indium. Okay, next that 49 plus 32. Okay, 32, that we get an 81. Am I right? 81 is the atomic number of thallium. TL. Okay, don't forget that. Thallium. Okay, anyhow, the atomic number of boron is 5, aluminium 13, and gallium 31, indium 49, and thallium is 81. Am I right? Next about the isotopes. Okay, just to read that one. Isotopes. Isotope boron isotope is isotope of boron is 11. Okay, then aluminium 27, gallium 69. Indium 115, thallium 205. Okay, these are the isotopes. Okay, try to learn this area, especially for this area. Don't forget to learn about the words of this boron. Okay, next about that atomic mass of boron, you have to learn it for the one-word question. Boron is 10.81. Aluminium 26.98. Gallium 69.72. Indium 114.81. And about the thallium 204.38. Okay. And about the electronic configuration of this group number 13 element, already we discussed that one. My dear children, this is the 11th standard portion. Once again, we can be recall how to write the electronic configuration of this element, that is group 13 element. First, you have to write that the rules how to write the electronic configuration. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, etc. Okay. First you have to cut here one cut. Second one cut. Third like that one cut. First we are taking only one. Second also we are taking only one. Next two we are taking 2p and 3s. Next we are again taking 2p and 4s. Next 3, that means 3d, 4p, 5s. Next again we are taking 3, 4d, 5p, 6s, like that, etc. Am I right? You are going etc. So start with here, ends with this arrow. Start with here, ends with 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 arrow. Am I right? First only 1, again also 1, next 2, again also 2, next 3, again also 3, next will be come 4. Okay, 4 like that. Okay, already we learned in the 11th standard thoroughly, clearly. Okay, I think that somebody is having me have some doubt. Okay, small doubt. So we just recall that one. Okay, anyhow, start with first of all we know that one. All S subshell we can be accommodate the maximum number of electron. The maximum number of electron is 2 for all subshell. So one box like that we can be accommodate the maximum is 2. Okay, minimum we can be accommodated 1. Second one maximum is 2. Next about that P subshell. Okay, P subshell we can be accommodate maximum number of electron is 6. Okay, minimum first start with single electron. Next again single electron. Next again single electron. Then paired. Am I right? Then pairing takes place. Am I right? Already we learned thoroughly in 11th standard. Okay, if you have any doubt, please ask me. Okay. Next about a D subshell also having 5 boxes. Am I right? That is 1, 2, 3, 4, 5. Dx, dxy, dy is set, dx is set, dx square minus y square, dz square. Okay, already, and also having f already we know that one. Okay, anyhow, we have start here because we are learning p block elements. Okay, p block elements only we are learning. So due to the f block elements we can be discuss about the f orbitals. Okay, now here first one, hydrogen. How will you write the hydrogen? The atomic number of hydrogen is equal to EC is equal to 1s1. Am I right? 1s1. Second one, helium is equal to EC is equal to, start with here, helium. In S subshell, the maximum number of electron is 2. So we can be accommodate 2 electron in the 1s subshell. Am I right? So 1s2. That's about the helium. What about the lithium? Atomic number is 3. Am I right? So how will you write? 1s2, start with here, 1s2, the maximum number of electron in X subshell is 2. Second, after finishing the 1s, we can be just jump to the 2s. So 1s2, the 2s we can be accommodate maximum 2, but we have only 1 electron because 3 electron having for the lithium. So 2s1. Can you write yes or no? What about the beryllium? Is equal to 4. How will you write the beryllium? Is equal to, start with here, 1s2, after finishing 1s, jump to the 2s, that is 2s2. I'm right. 1s2, 2s2. So 2 plus 2 how much? 4. 4 is over. Next about the boron is equal to 5. Boron, don't forget that atomic number is 5. Start with 1s, 1s2 is equal to 1s2. Second one, 2s2, Next one. After finishing 2s, jump to the 2p. Am I right? 2p. 1. So we have count that one. 2 plus 2, 2. 2 plus 2, 4. 4 plus 1, 5. So 5 electrons in the boron. What about the carbon is equal to, how will you write? Start with the here. Carbon, next element, carbon. 1s2 finishing. Second one, start with here. 2s2 finishing. Start here. So 2p2. Am I right? Is equal to 1s2. 2s2, 2p2. So 2 comma 2, 4. 4 plus 2, 6. 6 electrons for the carbon. What about the nitrogen? N is equal to 7. How will you write nitrogen? Start with here. 1s2, 2s2, 2p3. The maximum accommodation in the p subshell is 6. We have 3 only for nitrogen. Am I right? So how will you write? EC is equal to 1s2, 2s2, 2p3. What about the oxygen? How will you write the oxygen? Start with here. 1s2, 2s2, 2p4. Because the maximum number of electron in p subshell is 6. Up to 6 we can be accommodated in the p subshell. After finishing the p subshell, we can be enter the next one. Am I right? Yes or no? EC is equal to 1s2, 2s2, 2p4. Next one. Fluorine is equal to 9. How will you write fluorine? 1s2, 2s2, 2p5. 2p5. Fluorine is 9. 1s2, 2s2, 2p5. Am I right? Next about the neon. Atomic number is 10. How will you write? 1s2, 2s2, 2p6. Yes or no? 1s2, 2p2, 2p6. 1s2, 2s2, 2p6. Next about sodium is equal to 11. Am I right? Sodium is equal to 11. How will you write? 1s2, 2s2, 2p. We can be accommodated 6 electrons. So 6 completed. Next, we have one more electron that we can be occupied where? 3s1. So 1s2, 2s2, 2p6, 3s1. So, my dear children, you have to write the remaining elements. Everything you have to write the remaining elements. Okay, once again, you have to take return practice. Okay, then how will you write the short form? There is one short form. How to write the electronic configuration? Short form for writing, you have to select the nearest noble gas. Nearest noble gas. Am I right? So our family, boron family, we know that. Which are the elements in the boron family? That is boron, aluminium, gallium, indium, thallium. Okay. Who is the nearest inert gas? Nearest means backside of inert. Okay. Not the front, upcoming. No. Come to the backside. Okay. Nearest, that is nearest means for the boron is helium. Am I right? Yes or no? What about the aluminium? The nearest, don't tell about the upcoming. Come to the back side of this one. That is aluminium is which one? Neon. After neon only, we have aluminium. Not before. Am I right? Sorry, not after. Before we have to, before which inert gas element is occupying. That you can be taken as. Okay. So before neon is present. What about the gallium? Before argon is present, because the atomic number of gallium is 31, argon is 18. Am I right? So we can be select such a way like that. Okay. Next one, indium. What is the before neon? Before inert gas is present? Krypton. Okay, because the indium atomic number. What is about the indium atomic number? Can you remember? 49. So before indium, which inert gas is present? Krypton 36. Don't take xenon. Okay, there is a after indium. Okay, before indium we have to take. What about the thallium? Who is sitting in the before thallium? There is about the xenon 54. Gallium 81. Am I right? Yes or no? Can you understand, my dear children? So you have to take short form. How can you write the short form of the electronic configuration? First, I have to write about that boron. What is about the boron atomic number? Is equal to 5. How will you write the boron atomic number? EC is equal to 1s2, 2s2, 2p1. For here, I am using, I can use only for about the helium. Helium only because helium is occupying before boron. Okay, so for writing 1s, I am writing here helium because the atomic number of helium is 1s2, am I right? So instead of writing the 1s2, I am writing helium. Remaining you have to write. Remaining which are the element is, which are the orbital is there? 2s2, 2p1. This is the short form of boron. What about the short form of aluminium? Al, aluminium. Short form of aluminium means, short form of electronic configuration for aluminium means, how will you write? We can be select the nearest noble gas for aluminium. Who is the nearest noble gas for aluminium? Neon. Am I right? Neon. Neon. What is the neon electronic configuration? 1s2, 2s2, 2p6. For this much I have to write cut short and writing here neon. What's the remaining aluminium? After 2p6, we have to write 3s2, 3p1. Okay. Once again, I am writing the aluminum electronic configuration. Aluminum electronic configuration is equal to 1s2, 2s2, 2p6. After completing 2p6, who is the next one? 3s2. After completing again 3s2, who is the next one? 3s2 again is 3p1. Am I right? 3p1. So this much area means it goes to where? Neon. Am I right? Because the atomic number of neon is 10. 2 plus 2, 4. 4 plus 6, 10. Am I right? So we have to write as 1s2, 2s2, 2p6 is completed. Remaining which is occupying there? 3s2, 3p1. That we have to write here. Remaining. This area you have to write neon. Remaining you have to write 3s2, 3p1. Already we learned thoroughly in the 11th standard. Am I right? So if you have any doubt, please ask me. You must take written practice. Okay, written practice. If you are taking written practice, then only you can be easily write in the examination. Okay. Next, we can be discuss about that. How to write the electronic configuration of gallium. Okay, am I right? What is the atomic number of gallium? 31. Am I right? Yes or no? 31. So how can you write the electronic configuration? Start with here. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p1. Am I right? 4p1. Yes or no? So the D cell is completely filled. Am I right? S also 4s also completely filled. So in this it can be interchanged like that. The 3D goes to ender and the 4s come outside. Am I right? So how can we write the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. Yes or no? Okay. Here, this we can be used for who is the nearest noble gas for gallium means is argon. Am I right? What is the atomic number of argon? 18. How can you write the atomic number of argon? How can you write the atomic number of argon? Argon is equal to, EC is equal to 1s2, 2s2, 2p6, 3s2, 3p6. This is goes to argon. For writing this much you have to write argon. Argon. Who is the remaining there? 3d10, 4s2, 4p1. This is the short form of electronic configuration of gallium. Okay. Next about the indium, you have to take written practice for the indium and gallium. Okay. You have to write 2 times written practice. I am going fast. Okay. About the krypton, because the indium, who is the nearest atomic number, nearest noble gas of indium is about the krypton. Am I right? So indium atomic number, can you remember? Indium atomic number 49. So nearest inert gas is krypton. That is about the 36. Am I right? So 36 goes to krypton. The remaining you have to write. Okay. 49 minus 36. Yes or no? So we get 3. 13. Proton also may be having 13 electrons. So we have to write remaining. Remaining. Who is the remaining? Here we can be stored here. That means 4d10. Nearest is about the 4d10. 5s2, 5p1. Am I right? So 36 plus 10, 46. 46 plus 2, 48. 48 plus 1, 49. That is correct. Am I right? Next about the thallium. Okay, thallium. What is the atomic number of thallium? 81. Am I right? 81 is the atomic number. Next, who is the nearest one? That is about that xenon. Xenon. Xe. What's the atomic number of xenon? 54. Am I right? 54. 54. Here 81 minus 54. 11. Right? So it's about that 7. Am I right? 17. 17. How to count it? 17. The remaining. Who is about the remaining? It's about that we can use as the 4 of 14. Nearest is 4 of 14. Next 5D 10. 6s2. 6p1. Okay. Now we can be counting about that xenon is about the 54 plus 14. We get 8, 64 plus 10, 78 plus 2, 80 plus 1, 81. So it's correct. Okay. So how to write like this, such a way like that. Okay. Next about the atomic radius. Okay. That is about that atomic radius of boron. I think that about 1.92, aluminium 1.84, gallium 1.87, indium 1.93, and also thallium 1.96. Okay. Density, melting point, boiling point is everything how to learn thoroughly. Okay. Next about what are the chemical properties of boron. Chemical properties. Listen all of you. In this group, only one metal is about that. Only one element is about that metalloids. That is only boron. Remaining are the, we know that one. Remaining are the metals. Yes or no? In the periodic classification, remaining aluminium, gallium, indium, thallium. These are all, everything are the metal except boron. Except boron. Boron is the only one metalloids in this group. And it is a less reactive. Okay. It is a reactive when it at only the higher temperature. Many of these boron compounds is an electron deficient. That means shortage of electron. Am I right? Electron deficient. Okay. Anyhow, why it is happen means it is due to the small size and high ionization energy. Okay. Here, first one is about the formation of metal borides. How can the boron reacts with about the metal borides? Because listen all of you, many metal except alkali metal. Alkali metals we can be say about the X block element. Am I right? Sodium can be say hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These are all alkali metal. Am I right? We are saying the S block element including alkaline earth metal also. That is also an S block element. Am I right? Yes or no? But the alkali metal means hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These are all alkali metals. Okay. Anyhow, many metal except alkali metal forms borides with general formula. What is about the general formula here? MEXBY. What is about the X? X here ranging up to 11. Okay, we can do maximum number of X means 11. M11. Okay, we are using like that. X means here maximum we can be use 11 up to 11 value. And about what about the Y? Y means 1 to 66. Okay, or it may be higher. Okay, that is about that formation of metal borides. Okay, next about the direct combination of metal with borons. Very important question. Direct combination, because here metal on react directly with boron for n molecules. We are using n molecules. For example here, chromium metal. What is the formula for chromium metal? Cr is the formula for chromium metal. This one reacts with the n molecules of boron, and also the temperature is about 1500 Kelvin. What is the temperature here? 1500 Kelvin. We get chromium boride. Chromium boride. What is the formula? CrBn. CrBn. Chromium boride. Next about the reaction with boron trihalide. Boron trihalide. Okay. Here we have reduction of boron trichloride. Reduction of boron trichloride with one of the metal, that is about the tungsten metal. Okay, tungsten metal we are using here. What is the formula for boron trichloride? BCl3. Boron trichloride on reacts with metal tungsten W, and we get and the temperature means we are using here 1500 Kelvin, and the reduction means we are using hydrogen. Am I right? We are using hydrogen. Okay, so this hydrogen combines with 2 chlorine, because here having 3 chlorine. This hydrogen combines with 2 chlorine, we get 2 HCl. Okay, we get, because here having 2 hydrogen, am I right? 2 HCl. Okay, and also this boron combines with the tungsten metal, we get tungsten formula is, you know, that WB, am I right? And also the chlorine molecules also leaving out, Cl2 plus HCl. How to balance the equation? Here having 2 hydrogen, so make it 2 here. Here having 2 plus 2, 4 chlorine, so make it, you cannot balance, so make it here 2. If you make it 2 here, means 2 3s are 6. If can be used here, 2 2s are 4, 4 plus 2. Now the chlorine is also balanced. What about that? Boron, make it 2 here. What about the tungsten? About 2. So this also balanced. Am I right? So try to take it and practice. Next, one of the important question. Formation of hydride. One of the very important question. Formation of hydrides. One more question may be asked about that. This question. What happens? Boron trifluoride reacts with the sodium hydride. Okay. What happens? Boron trifluoride. Boron trifluoride reacts with sodium hydride. You have to write the equation is enough. Okay, try to write the equation there. Sorry, try to write the question there in front of the equation. First one, boron does not react with hydrogen directly. Okay, directly does not react. Because anyhow, the boron reacts indirectly with the hydrogen. Okay, indirectly with the hydrogen to form a variety of hydrides called borons. The very important question, my dear children. Very important question. Borons. What is about the borons? Borons, the formula is B2H2. Okay, B2H2. Borons, diborons. Okay, anyhow, we can be discuss that one. The simplest boron is diboron. What is the formula? B2H6. Okay, other larger borons can be prepared from diboron. Okay, anyhow, boron trifluoride on treatment with the sodium hydride around 450 Kelvin, we get diboron. Can you understand, my dear children? Here we are taking boron trifluoride. What is the formula for boron trifluoride? BF3. Boron trifluoride on reacts with sodium hydride. What is the formula? NaH. What is the formula for sodium hydride? NaH. Sodium hydride. We get diboron. What is the formula? B2H6. B2H6 plus sodium combines with fluorine. We get sodium fluoride, that is NaF. Dear children, the product side we have how much boron is there? 2 boron, so make it 2 here. How much hydrogen is there? 6 hydrogen, so make it 6 here. Sir, no. Can you understand, my dear children? Can you understand? Here, how much boron is there? 2 boron, so make it 2 here. How much hydrogen is there? 6 hydrogen, make it 6 here. So how much fluorine is there? 6 fluorine. How much sodium is there? 6 sodium, so make it 6. So now the equation is balanced. Try to learn this equation thoroughly. Equation is enough, my dear children. Okay, try to learn with the temperature. Don't forget to write the temperature. 450 Kelvin. What is the product name? Diboron. Okay, next about the formation of trihalide. Formation of trihalide. Boron reacts with one of the halogen. One of the halogens. Commonly we can be taken halogen group is X2. X2 refers to halogen. Maybe fluorine, chlorine, bromine or iodine. Okay, yes or no? So I am taking X2. We get BX3. Okay, boron trihalide. How can you balance the equation? Here having X is 2, here having 3. So make it 2 here. Make it 3 here. The halogen balance. What about the boron? Make it 2 here. Now the equation is balanced. Next one of the book bag questions. A very, very important question. Formation of boron nitride. How is boron nitride prepared? That's a question. Boron reacts with dinitrogen. Boron, what is the formula of boron? B. On reacts with dinitrogen, that is N2, we get boron combines with nitrogen, we get Bn. How can you balance the equation? How much nitrogen is there? 2 nitrogen, so make it 2 here. How much boron is there? 2 boron, make it 2 here. So here give the symbol, heating symbol, because at the high temperature then only boron reacts with nitrogen. Okay, at high temperature. Can you understand, my dear children? Next about the formation of oxide. Formation of oxide. Boron is heated with oxygen at around the temperature is about 900 Kelvin. Boron reacts with oxygen at about 900 Kelvin. We get B2O3. What is about the B2O3? Boron trioxide. Boron trioxide. How can you balance the equation, my dear children? Here having 2 boron is there. Here having only 2 boron is there, only 1 boron is there. So here having 2 oxygen, here having 3 oxygen. So first you have to make it 2 here. Yes or no? So 2 into 3 is equal to 6 oxygen. So make it 3 here. Oxygen, oxygen balance. 2 2s are 4 boron is there. So make it 4 boron. Can you understand, my dear children? Try to take written practice. Next one question. What happens? Boron reacts with oxidizing acid. That is, simply we know about the mineral acid. Am I right? Mineral acid means sulfuric acid, nitric acid, hydrochloric acid. Already we learned in the 10th grade. Am I right? Here we are, sulfuric acid and nitric acid are used as the oxidizing agent. Am I right? So we are using the name here, oxidizing acid. Okay. Anyhow, halo acid have no reaction with boron. Halo acid. That means, for example, halogen. One of the halogen combines with one of an acid. We are saying that hydrochloric acid. Am I right? What is the formula for hydrochloric acid? HCl. Okay. We are having HCl. So we are saying halo acid. Am I right? So this halo acid have no reaction with the boron. That means hydrogen chloride cannot be react with the boron. What's the remaining acid? About the remaining acid means about the sulfuric acid, and also we can be say nitric acid. Okay. Boron reacts with oxidizing acid such as sulfuric acid and nitric acid to form boric acid. Boric acid, very, very important term. Yesterday we learned about the boric acid. Am I right? What is the formula for boric acid? H3BO3. Okay, sir, no. Boric acid. Did you learn yesterday? Yes. Boric acid. What is the formula? H3BO3. So anyhow, boron reacts with the sulfuric acid. What is the formula? H2SO4. H2SO4. Okay, my dear children. So boron reacts with sulfuric acid. We get boric acid. What is the formula? H3BO3. And also here the evolution of sulfur dioxide, SO2. What is the formula for sulfur dioxide? SO2. Okay, my dear children. So how can you balance the equation? Here equation balance is very, very important. Okay. So how it can be easily balanced the reaction. So first you have to make it 2 here. So how much boron is there? 2 boron. So boron is balanced. Am I right? So how much here sulfuric acid? Can you balance here sulfuric acid? Here 2 3s are here having hydrogen. 2 into 3 is equal to 6. So make it 3 must. Okay, yes or no? Because we cannot use 2 here. So here having H3BO3 means 2 into 3 is equal to 6. So make it 3 here. 3 into 2 is equal to 6. So how much sulfur is here having 3 sulfur? Now the equation is balanced. Okay, my dear children, if you have any doubt, don't worry about that. Please send a message to me. Okay, I will explain once again. Okay, sir, no. Next about boron reacts with the nitric acid. What is the formula for nitric acid? HNO3. Am I right? Yes or no? So boron reacts with the nitric acid. We get boric acid. What is the formula? H3BO3, and also the evolution of NO2. How can you write the equation? How can you write the H3BO3? How much hydrogen is there? My dear children, tell me how much hydrogen is there. Tell me now. 3 hydrogen. So make it 3 here. So H3BO3. Yes or no? So how much nitrogen is there? 3 nitrogen. Yes or no, my dear children? So now the equation is balanced. Yes or no, my dear children? Next about the very important. Very important. How is sodium borate prepared? Okay, how is sodium borate? What is the formula for sodium borate? Na3BO3. Don't forget, today I will ask the question. What is the formula for sodium borate? What is the formula for boric acid? Am I right? What is the formula for boron nitride? Bn. Okay, boron nitride Bn. What is the formula for boron trioxide? B2O3. What is the formula for boric acid? H3BO3. What is the formula for sodium borate? Na3BO3. Okay, so how is sodium borate prepared from boron? So boron reacts with the sodium hydroxide. Okay, we get the sodium combines with the boron, and also this oxygen we get sodium borate. What is the formula? Na3BO3 plus H2. I'm right here having H2. Yes or no? So how much is sodium? We have to balance the sodium. Here having 3 sodium. If we are using 3 now, we cannot balance the equation. So we have to make it 2 here. Okay, make it 2 sodium here. So 2 into 3 is equal to 6 sodium. Yes or no, my dear children? 2 into 3 is equal to 6 sodium. So make it 6 here. 6 sodium. Sodium are balanced. Am I right? Yes or no? How much boron is there? 2 boron. So make it 2 here. So how much hydrogen is there? 6 hydrogen. So make it 3 here. 3 into 2 is equal to 6 hydrogen. Next about what are the uses of boron? Am I right? What are the uses of boron? Okay, at least I think that here are having 3 or 4 uses. You have to select any 3 is also enough. Okay, that means the boron has a capacity to absorb neutron. Okay, hence the isotopes B10, that's a boron. B10 is used as a moderator and nuclear reactor. One of the boron is used as a nuclear reactor. Try to take the key points. It is used as the moderator in nuclear reactor. Amorphous boron is used to rocket fuel integer. Okay, integer, that is for making a fuel. Next about boron is essential for cell walls of plants. Next, very important is about that the 4th point. That is boron have a many applications in medicine. Okay, in medicine, what is about in, for example, eye drops, antiseptic, washing powder. Okay, these are all contained in boric acid, and also boron is also very important. It is used in the manufacture of Pyrex glass. Pyrex glass is, that is we are using for the laboratory purpose. I'm right? The lab we are using some test tube, some conical flask, some beaker. I'm right? These are all also made up from borosilicate glass. Okay, borosilicate. That we are simply short form we are saying Pyrex glass. That means it does not break in a heating. Even in heating, okay, that's we are using lab purpose, and also manufacture boric oxide. These are all used. Okay, very important question. Okay, so okay, my dear children. Anyhow, today I am giving one assignment. Which assignment means the first one is about that formation of hydride. Today assignment taken right, my dear children. Formation of hydride. Formation of hydride. Second one, boron nitride. Third one, formation of oxide. And write any three uses. Any three uses of boron. Write any three uses of boron. Okay. So my dear children, learn thoroughly. Okay. And send to me. Okay. Thank you all of you. Thank you. Have a nice day.